Good day, everybody. Today we'll be talking about chemical composition. Previously, we have learned how to convert one unit to another using the one-step conversion or sometimes, if necessary, multi-step conversion. Today, we are going to learn how to apply what we have already learned into the calculations related to chemical composition. Let's quickly review what we learned about unit conversion. The first type of unit conversion is the one-step one. For example, the first type we learned is converting inch to centimeter, or the opposite, or centimeter to inch. Right? For example, here's the question: how many centimeter in 13.16 inch? So when we look at this question, first we write the conversion map or the solution map. You are given number of inches and you want to convert this to centimeter. Okay? To set this up, we write what is given, which is in inch. Then we do need to know this needed to be converted to centimeter, so we leave this inch as the denominator and numerator will be centimeter. Okay, and in the parentheses over here, that is the conversion factor, which you already know. That's 1 inch is 2.54 centimeter. Okay, so we fill in the numbers over here. 1 inch is 2.54 centimeter, and we are given 13.6 to begin with. We want to convert this 13.16 inch, okay, into centimeter. So inch over here is cancelled out. Do remember 2.54, this number happens to be an exact number, which means in the consideration of sig figs, 2.54 would have indefinite number of sig figs. So for the whole thing, again, this has indefinite number of sig figs. For this reason, the whole calculation, which is a multiplication or division, you will keep 4 sig figs, because the other one is unlimited number of sig figs or indefinite number of sig figs. After the calculation, your calculator gives you a number which reads 33.4264, but you do need to keep 4 sig figs because the other one is unlimited number of sig figs. So we keep 4 sig figs. This becomes 33 point, you round it to that number 2, so 0.43 centimeter. So that's the first question. Similarly, if we want to convert centimeter to inch, we just simply use this one-step procedure. Okay, let's look at that question. For example, I ask you, how many inch or inches in 26.5 centimeter? Okay, so when you set this up, first the solution map, we need to convert, because we are given 26.5 cm, so cm is known. That's the starting point. We want to convert this to inch. Okay, we set it up without the numbers first. You start with what is given, which is centimeter in units, times a unit factor or conversion factor whose value is 1. So whatever number times 1 does not change the value. Okay. By the way, we have 26.5 centimeter to begin with. Okay. So to convert centimeter to inch, centimeter must be cancelled out. So inch must be the numerator. Okay, and we do know the numerical relationship is 1 inch is 2.54 centimeter. Do remember, again, 2.54 happens to be an exact number. So it has a limited number of sig figs. So for the whole thing, we keep 3 sig figs. Right? After you do the calculation, the calculator gives you a number that reads 10.433. All right. So you will have to round it to 3 sig figs, which means round it to the digit of 4. So this will be 10.4 inch. That's the first type of calculation we learned. The second type of calculation is a multi-step calculation, which is, for example, what if you want to convert feet to centimeters? Usually you do not remember the direct numerical relationship between feet and the centimeters. So you cannot do this calculation or this conversion using one step. Rather, you would have to convert feet to inch first. Then you can convert this to centimeter. Okay. For example, if I have this question, how many centimeter in 1.310 feet? So similarly, we write the solution map first, which tells you what unit should be converted to a different one than another one. Okay, so as I said, foot must be converted to inch first, then you convert this to centimeter. When you set up the calculation, we start with what is given, which has foot as the unit. So it's 1.310 foot. Okay, but first you need to multiply this by a certain conversion factor. So that's our step 1. After step 1, as you see in the solution map, you should convert feet into inches. Okay, so for this reason, in this conversion factor, feet must be the denominator, so it can be cancelled out. At the top, it should be inch. So after step 1, you will have inch as the intermediate unit. We do know 1 feet is 12 inch. All right. So for the second step, so after this, we do have inch as the unit already. The second step, we convert this inch into centimeter. So we multiply another conversion factor or unit factor. So now we got to convert inch to centimeter. We got to cancel out this inch we have. So for this reason, we should have inch as the denominator for the second conversion factor or unit factor. So we can cancel those two out. Inch can be converted to centimeter using 1 inch is 2.54 centimeter. Okay. Do remember this number 12 and the number 2.54, they happen to be exact numbers. Okay. So for this reason, hashtag is exact number. Right. Hashtag represents number. So both of them have unlimited number of sig figs. Okay. So for this reason, we keep 4 sig figs for the whole thing. When you use your calculator, we have this number, 39.9288. Okay. We need to keep 4 sig figs, which means we round it to that number 2. So the next digit is 8, which is greater than 5. So we round it up. This gives us 39.93 centimeter. So that's the second multi-step conversion. Next example, which is not going to be used for today's lecture, but we're going to review it anyway. Next is converting, for example, squared to, for example, let's say inch squared, or anything. It could be cubed, for example, inch cubed to feet cubed, or anything like, for example, centimeter squared to inch squared, etc. Okay, so in this situation, to remember the conversion factor. For example, if I have the last example here, if you want to convert centimeter squared to inch squared, okay, so what are you going to do? Let's use this example. We ask you, if we have a 16.81 centimeters squared, we ask you how many inches squared you would have from this conversion. So here's how we do it. We always start with what you are given. So here is 16.81 centimeter squared, right? That's what is given. That has centimeters squared as the unit. Times, do remember, the conversion factor is 1 inch over centimeter. Okay, do remember, to cancel out centimeter squared, the whole thing must be squared, not just the unit squared, or else it's not the same. For example, if 1 meter is 100 centimeter, 1 square meter will not be 100 centimeters squared. It will be 100 centimeter whole thing squared, which means, so what I'm talking about is, if, this is just one example, okay, if 1 meter squared is 100 centimeter, okay, I mean, if 1 meter, that's correct, okay, then 1 meter squared would be not 100 centimeters squared. That's wrong, okay? It's rather 1 meter squared. It's the whole thing squared, which means that's 100 times 100 centimeters squared. Okay, but why is that? Because the conversion factor, the whole thing should be squared. Do remember, the whole thing inside the parentheses over here, they have a value of 1. So the whole thing squared will still have a value of 1. That's why we squared this thing, right? So it's 2.54. So when you do square of this whole thing, that means when you do the calculation, 2.54 is also squared. So let's write this out. It's the same as 16.81 centimeters squared. Now, inside the parentheses, this 1 is squared, inches squared, 2.54 is squared, centimeters squared. So when you do the calculation, it becomes 1 squared and inch squared, 2.54 squared times centimeter squared. So centimeter squared is cancelled out, leaving inch squared as the desired unit. So the calculator gives you is 2.610205. But we're going to convert it, do remember again, 2.54. It's not 3/6 figs because it is an exact number. It has unlimited number of sig figs. For this reason, we keep 4 sig figs for this whole thing. So we round it up, it will become 2.1610. So that's the 4th sig fig. Okay, the unit would be inch squared. Okay, so that's how you do this conversion. So next, we are going to introduce to you different types of relationships, similar to what we have already learned. So far, we have learned something like 1 inch is 2.54 centimeter. 1 feet is 12 inches, etc. So we're going to introduce to you some new relationships, and hopefully we'll also be able to use those new relationships to do unit conversion. And all the unit conversions so far we have learned, they are sort of not related to chemistry. They are more pure math. But next, we are going to introduce to you how to convert chemical quantities. The first new relationship we are going to introduce to you is so-called Avogadro's number. All right, so what is Avogadro's number? We learned before that 1 dozen is 12. No more, no less. Basically, this unit dozen is a number. All right. So similar to what is 1 mole? 1 mole is just a big number. All right. Rather than being a small number like 12, it is a huge number, which is 2.022 times 10 raised to 23. Okay. Remember, mole is just a number. I'm going to use hashtag to represent a number. All right. So if you want to convert a number to a unit, so hashtag is the number. If you want to convert to mole, you use the mole definition, which is 1 mole is 2.022 times 10 raised to 23. Right. What if you want to convert backward? So mole to number, you use the same unit, the same numerical relationship. Just like if you want to convert inch to centimeter, you use 1 inch is 2.54 centimeter. You want to convert centimeter to inch, you still use the same numerical relationship. So that's the first new relationship. 1 mole is this number. 1 mole of anything is that number of anything. So if this number is referring to any chemical items, for example, 1 mole, so let's say 1 mole of anything is 6.022 times 10 raised to 23 times anything. For example, 1 mole of copper atoms will be this 6.022 times 10 raised to 23 number of copper. Or sometimes we specify as all copper atoms, but you don't have to write it. If you do, it's still correct. We just want to specify that copper is copper atoms. Okay? All right. That's the first new relationship, which is mole definition. So that comes from, and that number we call this Avogadro's number. So this is the mole definition. Okay, by the number. All right, that's the numerical value. Okay, but how did we get this number? This number, more exact definition would be the numerical value of mole is defined as being equal to the number of atoms in exactly 12 grams of pure carbon 12. What does it mean? That means 12 grams of pure carbon 12 will have 1 mole of carbon atoms inside. Okay. According to this definition, we have another important numerical relationship, which we call a molar mass. Okay. So what is we're going to introduce to you another relationship. That's the molar mass. So what do you mean molar mass? Molar mass just tells you how many grams of one thing is inside 1 mole of that thing. Okay, so we do know 1 mole of any substance, okay, weighs the formula mass number of grams. Okay, so this is so-called molar mass. This is not minus. Okay, this is just a dash over there. So this is so-called a molar mass. Right, that's molar mass. Okay, so I'm going to say it one more time. What is molar mass? Molar mass tells you how many grams of any substance inside 1 mole of that sample. Okay, so for example, 1 mole of copper will be the formula mass grams of copper. When you look it up in the periodic table, look at your periodic table now. copper has an atomic mass of 63.33. Remember, 1 mole of any substance will weigh exactly the same as the formula mass grams. Formula mass of copper is 63.55. So 1 mole is 63.55 grams. Okay. Similarly, for example, how many grams of water inside 1 mole of water? Remember, 1 mole of anything will weigh formula mass grams of that thing. So formula mass of water, when you calculate, it's 2 hydrogen plus 1 oxygen. So you look at the periodic table and find the atomic mass for hydrogen and oxygen. So it's 2 times, but sorry, it's not a 1 times. Okay, it's 2 times 1.01 plus 1 times 16.00. That gives you 18.02. So 1 mole of water will be 18.02 grams of water. They are equivalent. That gives you the numerical relationship. Remember, this will not be given for you. All right. For example, I can ask you, what's the molar mass? So I'm going to ask you, what's the molar mass for CO2? Okay. This will not be given to you. It will not be provided in your exam. You will have to know the molar mass definition, which means how many grams in 1 mole. Okay. And we do know it's formula mass grams in 1 mole. So basically we need to calculate the formula mass for carbon dioxide. For formula mass for carbon dioxide, it's actually 2 oxygen, okay, plus 1 carbon. So if you add it together, 2 oxygens, 2 times 16.00 plus 12.01. Okay, so this gives you 44.01. Or in another word, 1 mole of CO2 is the same as 44.01 grams of CO2. Or many times we write it differently. We say the molar mass of CO2 is 44.01 grams per mole. Okay, so this is called the molar mass of CO2. Okay, so similarly we can say over here, look at this situation, we can say the molar mass of copper, we can write it differently. Rather than writing this as 1 mole of copper is 63.55 grams of copper, we can also write it as molar mass of copper is 63.55 grams per mole. So that's 2 different ways to write molar mass. Okay, you can write the equation, or you write something like grams per mole. All right, let's work on a few examples and see how we can convert mole to a number using Avogadro's number or mole definition. Another example would be how to convert mole to grams or grams to mole. All right, convert 3.5 mole of helium to number. Okay, so basically in this example, it's mole to a number. Sometimes I simply write the solution map as you want to convert mole to hashtag means number to a number. How do you do that? So apparently you are given moles to begin with. So you do know you have 3.5 mole to begin with. Okay, you want to multiply a conversion factor that relates mole and the number. We know 1 mole is 6.022 times 10 raised to 23. So for this reason, we know mole in the conversion factor must be cancelled out, or it must serve as the denominator. So we cancel this. We can cancel this out over here. Okay? All right. But mole to a number, so the top is a number. So what number is that? We do know 1 mole is 6.022 times 10 raised to 23. Okay? So that's the setup. In this case, it's referring to helium, so that's why in this equation we add helium here. But you don't have to in this simple situation, because for the whole calculation, everything is the same, referring to the same helium atom. So you will not get confused if you don't specify helium. But if you do, that's a very good practice. Okay, so you do the calculation, you keep 2 sig figs. Here you have 4 sig figs, so you keep 2 for your answer. That's why you have 2.1 times 10 raised to 24. All right. Let's. So here we learned how to convert mole to a number. Can we convert a number to mole? Sure we can. We use the same Avogadro number to do that. So convert certain number of silver atoms to the mole. Okay, we have a number. So I can, a lot of times I just write it this way: convert a number to mole. Okay, how do you do that? You started with the number, which is over here, 1.1 times 10 raised to 22. Over here, everything is referring to silver. So if you don't specify silver, it's fine. But if you do, I'm going to demonstrate this way to you. So you just write silver. But do you have to say silver atoms? You don't have to. Because if you write Ag, it is referring to silver atom. If you write CO2, that is referring to CO2 molecule. Okay? So you don't have to write atoms. But if you do, it's okay. So times, do remember, we need to convert, this one is the number. We need to convert it to, so this is a number over here. We need to convert this to mole. What is the relationship? It's 1 mole is 6.022 times 10 raised to 23. Since we are referring everything to Ag, so here, this is silver, Ag, silver. Okay? All right. So you have 2 sig figs. You keep that, so that's why when you can do the calculation, here's the number you have. All right. I hope you do practice a lot with this type of conversion. Okay, practice is the key. The calculations themselves are not that difficult. All right. Now let's do another conversion. So far we have learned 2 things: convert mole to a number, or a number to mole. That's the one-step procedure, similar to inch converted to centimeter, or centimeter converted to inch. One-step procedure. Okay. We are going to do another conversion, which is also one-step procedure, converting grams to mole. Do we know grams and moles are related? Yes. That is grams and moles relationship. That's called a molar mass, right? So what is molar mass? Molar mass tells you 1 mole of anything weighs formula mass grams of that thing. So we do know grams and moles relationship is so-called a molar mass. All right. In this example, we are asked to calculate the number of moles of carbon in certain grams. Do remember, diamond is made of carbon atoms. Okay, so don't get confused over here. So it's asking you certain grams. Can you convert it to moles? So when you do the solution map, you simply write grams to mole. Okay, but do you have to write carbon here? Yeah, you can, but you don't have to. Here you specify carbon because everything is related to carbon. Sometimes you don't have to write it out. But if you want to, you can specify everything as carbon. Okay, so you have 0.58 grams of carbon to begin with. Then you want to convert grams of carbon to mole of carbon. Okay, you don't have to write carbon because we are referring to exactly the same thing all through the calculation. All right. So what is the mole and the grams relationship? Mole and the grams relationship is 1 mole of anything is formula mass grams. And do remember, this question mark, this will not be given for you. You have to be able to calculate that by looking it up in your periodic table. Basically, you calculate the formula mass for that very thing. For diamond, carbon is the formula. So carbon is the formula. So 1 mole of carbon is how many grams of carbon? Oh, you look it up for carbon, the formula mass is 12.01. So you do know it's 12.01. That's why you have 1 mole over 12.01. Always keep a periodic table with you. Okay? So that's why you have to set up like this, which is exact the same as what I just talked about. You keep 2 sig figs, okay, because the other one gives you a 4 sig figs. So you keep the fewest number of sig figs in multiplication or division. You have 4.8 times 10 raised to negative 2 mole of carbon. All right. The conversions that we have learned so far in this chapter, they are all one-step procedure. But can we convert, for example, using a multi-step procedure? For example, if I ask you, if I have a certain number of grams of one thing, I ask you, can you convert this to a number? Again, hashtag refers to a number. All right. We do know you cannot just measure out certain number of grams of one thing, then you say, oh, I'm going to count how many number you have. No. Basically, you need to build the bridge, find the intermediate unit, because we do know grams can be converted to mole, and this is molar mass, right, definition, and mole can be converted to a number using Avogadro's number. Okay, that's exactly what I'm going to show you. Let's look at that example. How many, this is a number, how many is a number apparently, right? How many atoms, okay, in certain number of grams. So the original map, solution map you would have, hey, can you convert grams to a certain number? Sorry, you cannot do that directly. As I demonstrated to you just a moment ago, grams must be converted to mole first, and then mole can be converted to a number. Okay, and here we are referring everything to aluminum. In this example, as I said, if it's referring to the same thing, we don't have to indicate that, but if you want to, you can. So that's why you have something that looks very similar to mine. Okay, so when you do the calculation, you are given 16.02 grams aluminum. First, that's the first step. Okay, you need to convert grams to mole. So when you cancel out the grams of aluminum, so we must have grams of aluminum as the denominator, and then you convert it to mole of aluminum. So 1 mole is formula mass grams. Look it up in the periodic table. For aluminum, you have 26.98. That's why we have 26.98 over here. Now the next step, step 2, you need to convert the mole of aluminum to number of aluminum. So 1 mole aluminum is 6.022 times 10 raised to 23. Okay, so you write this whole thing. Have you noticed? That's exact the same setup as you see over here. You see? All right. Then you keep the correct number of sig figs. You end up with 3.62 times 10 raised to 23 aluminum atoms. Okay. All right. Let's do another conversion. And this conversion is a little bit easier. Okay, basically, look at this question. Every time before you get started, I want you to analyze what is being asked. What is known, what is unknown. All right. So here you are given certain number of moles. We want to calculate how many grams you have. So it's mole to grams. Everything is referring to water. You don't have to indicate water, but if you do, it's fine. All right. for multi-step procedure, if you have different species, then you will have to indicate the species. Okay, so here it's mole to grams. Mole and gram relationship is the molar mass. So you calculate the molar mass for water, or the formula mass grams. You have 2 hydrogen and 1 oxygen. 2 hydrogen. So basically 2 hydrogen plus 1 oxygen. So you do know 2 hydrogen plus 1 oxygen. You end up with 18.02 grams per mole. After you do the calculation, you start with moles. So for the conversion factor, you should cancel out this. That means mole of water must be the denominator in this conversion. Okay, so you end up with the correct calculation. Right. Let's do another example, a multi-step example. Previously, we learned how to convert grams to a number using mole as the intermediate. Right, that's the whole procedure. Now we're going to tell you the opposite procedure. Can you convert certain number to the mass? Or in other words, a number, can you convert to mass? No, you cannot do that directly. But we do know a number, or the hashtag representing the number here, can be converted to mole using mole definition. 1 mole is 6.022 times 10 raised to 23. Then mole can be converted to grams using molar mass. That's exactly how you do it. Okay? So in the solution map over here, you have a number. That's the number of NO2. All right, everything is NO2, NO2. Okay, so you convert to mole, then you convert to grams. So you set up this. Let's do this step by step. All right. For example, you have a number. We're going to write out this number. Okay, so that's the number you have. Right, 4.78 times 10 raised to 23. Okay. In this case, as I said, it's all NO2. This time I'm not going to write NO2. Okay? You're going to convert this number to mole. Hey, that's the first step. Convert to mole. So you do know the number must be at the bottom. Mole must be at the top. 1 mole is 6.022 times 10 raised to 23. So after this, you have a mole as the unit because the number they cancel out. Okay? Now, next. Step 2, you need to convert mole to grams. So you do need to cancel out mole, then leave grams as the desired unit. So 1 mole of NO2 is how many grams? Remember, mole and gram relationship is so-called molar mass. So you need to convert NO2. Okay, let's NO2, this will have 1 nitrogen plus 2 oxygen. So when you do this calculation, this gives you 46.01. Okay, look this up in your periodic table. All right, so after you do this calculation, we know we can write it as grams per mole as the unit. Or you can write 1 mole is 46.01 grams. Okay, so 46.01. Okay, so mole is cancelled out. You leave grams as the last unit. And after you keep the correct number suffix, you find out that we have 365 grams of NO2. So for the multi-step conversion, you can also do it very similarly to what we have learned previously, similar to foot converted to inch, then back to centimeter. Let's quickly summarize what we have learned over here. First, we have introduced to you how to convert mole to a number or a number to mole using Avogadro's number. 1 mole is 6.022 times 10 raised to 23. Second, we talked about how to convert grams to a number by converting grams to mole, then back to a number. We also talked about how to convert a number to grams. We first convert number to mole, then mole to grams using molar mass relationship. Next, we are going to show you how to use the formula themselves to derive some relationship. And you'll be able to do that just by following me. So, for example, in one CO2 molecule, we have one carbon. The one is not written, which is implied. We also have two oxygen atoms. So if you write it this way, we can write one CO2. You don't have to write molecule because we know CO2 is a molecule, okay? Is 2O. So if you want to simplify, you say 2O is one CO2. Okay, if you want to specify oxygen is an atom, so you can write two oxygen atoms is one CO2 molecule. That's also the same. Okay, similarly, if you do 2 dozen, it's 2 dozen. Will be the same ratio. 2 dozen, it would be 2 to 1 ratio, as if it's the same as 2 oxygen is 1 CO2. Dozen is a bigger number, but molar is an even bigger number. So when you read this, when you look at CO2 molecule, we can read it as 1 mole of CO2 is 2 moles of oxygen, okay, which is similar to 1 CO2 is 2 oxygen atom. You see that? That's how they are related. Okay. So by reading the formula, you will see the molar ratio. So I'll give you another example. For example, for table sugar, which has a formula as C12H22 and O11, we can, from this, we can derive the implied information, the hidden information. We can say 1 mole of this whole thing, table sugar, which has this formula, will give you, for example, if I'm looking at hydrogen, you would know hydrogen. It's 22 mole of hydrogen atom. It's H, not H2, okay? All right. And we can also say this is gives you 11 mole of oxygen atom. Can you do that? Sure, absolutely. You can actually relate any, you can relate carbon to hydrogen. It would be 12 moles of carbon relates to 22 moles of hydrogen. Okay, we can derive a lot of information just by simply looking at the chemical formula. So let's see how we can use this kind of a relationship and do a calculation. So in this example, we ask you find the mass of sodium in 15 grams of sodium chloride. So now over here, I want you to pay special attention. Okay, you have NaCl to begin with. Okay, we have grams of that. Now we ask you to convert this to the mass of a different thing. That's a different thing. That's sodium. Okay, so you want to convert that. So do remember, in this case, you have two different species involved in the calculation. You must indicate the species clearly. Previously, we very often mentioned, we don't have to include carbon or any other species, because all through this calculation we are referring to the same thing, but over here it's not. Okay. So how do you convert grams to grams? So we started with grams of NaCl. How do you convert grams of sodium? Remember, very often, if you try to find the bridging or the connecting units, mole is very often used. So basically what we're going to do is, first, we convert grams of NaCl to moles of NaCl. Then we convert moles of NaCl to moles of Na. How do we relate this to? By looking at we relate this to just by looking at the formula. 1 mole of NaCl will have 1 mole of Na in it, because Na, when you look at NaCl, hey, that hidden one is not written. You see that? That's how you get this relationship. 1 mole of NaCl will contain 1 mole of Na. Okay, so let's see how we write this whole thing after we look at the solution map. Okay, so basically we have 3 steps: 1, 2, 3. So the first step, remember, we have grams, which is 15 grams of NaCl to begin with. We want to convert to more of NaCl. Now we have to indicate. This is if you write moles over here, that's totally wrong, because we need to convert grams to moles. So you will have to write grams here so it can be cancelled out. It's grams of NaCl converted to mole of NaCl. 1 mole is formula mass grams. So how many grams? It's 1 sodium plus 1 chlorine. Folks, so far we have done many calculations already. So you please do this calculation. 1 sodium is 23.55. Then you add 1 chlorine, 35.45. You add it together. Okay. So you have a 58.44. Okay. Right. If you look it up in different periodic table, the number might be slightly different. Okay. So the second, this is the first step. Now you look at second step. We got to convert moles of NaCl, one thing, to a different thing, sodium. Okay, and we do know they are related by looking at the formula. So remember, you need to convert mole of NaCl. This needs to be cancelled out. That's why I have moles of NaCl. Needed to be converted to not Na, but moles of Na. And we do know by looking at the formula over here, is 1 mole is related to 1 mole. They happen to be 1 mole. Okay. Then we have mole of Na sodium needs to be converted back to grams. Why do we use this one? Not the other one which has moles over the top, because we want to cancel out moles of Na. Okay. So mole and the grams relationship, as we mentioned, that's molar mass. 1 mole is formula mass grams. Look it up in your periodic table. You know it's 22.99. That's how you get that 22.99. Okay? All right. So you do the calculation. You keep the correct number of sig figs. This gives you 5.9 grams of sodium. Okay? Let's go over this for one more time. First, you start with grams of NaCl. This needs to be cancelled out. Okay, grams convert to mole. That's why grams is at the bottom for the first conversion factor. Okay, how did we get 58.44? We look up the atomic mass for sodium and that of chlorine and add it together. We look this up in the periodic table. You come up with 58.44. All right. Okay. Now let's switch gear and talk about a similar topic, which is mass percent. So what is mass percent? Mass percent is defined as the mass of a certain element in the sample of the compound divided by the total mass of the sample. Okay. For example, what is the mass percent of chlorine in dichlorine and CCl2 and F2. This is a freon actually. Okay, so how do you do this calculation? Basically, you do need to know how many chlorine you have. Then you do the calculation. Okay. By the way, this formula is written wrong. It's actually a C2Cl4F2. Okay, the formula is written wrong. Sorry about it. Yeah. So it should be C2Cl4F2. So inside this formula, you see you have 4 chlorines over here. So that's why you have 4 chlorine. You calculate the total atomic mass for 4 chlorine. Each chlorine is 35.45. You add it together. Now you calculate the total for the formula. But in this formula you have 2 carbon, that's why 2 carbon, 4 chlorine plus 2 fluorine. You add it together. Then you do the division between the two. So 4 chlorine divided by the whole formula times 100%. That gives you the correct percentage. Keep the correct number of suffix, 4 suffix in this example. Okay, so mass percent. Let's do another one, for example. How do you do the mass percent for for H2O? I want you to calculate the mass percent of hydrogen. How do you do that? So when you do this calculation, apparently in this H2O formula, you have 2 hydrogen atoms. Okay, so when you do this, it's 2 hydrogen atoms divided by the whole thing, H2O. Okay, times 100%. So 2 hydrogen is 2 times 1.01. Then 2 hydrogen plus 1 water, right? 2 times 1.01 times, not times, it's plus, because it's added together. 16, 1 oxygen, 16.0, it's, okay, times 100. So let's do a calculation. This gives us 11.2. 11.2%. Okay. All right. Now we have one topic left. That's one of the most difficult topics in this whole chapter. I hope you've spent a lot of time going through the procedure and make sure you know the detailed steps to solve the problem. That is how to find the empirical formula from the mass or mass percent composition. If we give you the mass for each component element or the mass percent for each component element of a compound, can you find the empirical formula? Okay, so we'll tell you how to do this in a little bit. But what is the empirical formula? Empirical formula just gives you the smallest whole number ratio of each element or atom in the compound. Okay, it's not the specific type of each atom. So for example, if you have C6H6, that's the chemical formula. If you recall, we have already talked about this in different representations of compounds, right? We are reviewing this. So that's the chemical formula, which tells you exactly how many atoms in each formula unit. In this formula, we have 6 carbons, okay, 6 carbons and 6 hydrogens, okay? If you simplify the ratio to the smallest whole number, then we have so-called empirical formula. So if you divide by 6 for carbon and hydrogen, this becomes a C1 and H1, or simply CH. So that's so-called empirical formula. Okay, I'm going to give you another example. For example, if I have C3H6O3, okay, if this is the chemical formula, can you find an empirical formula? Yes, we need to simplify everything. If we divide every number by 3, remember you got to divide every number, or else the ratio will not be the same for the whole formula. That means it will be wrong calculation. Okay, so if you divide by 3, C carbon will become 1, H will become 2, O will become 1 as well. So that's the empirical formula. Okay, give you one more. For example, if we have C3H6O, if this is the chemical formula, or this indicates the exact number of atoms in this formula. Okay, if this is a chemical formula, can you convert this to empirical formula? Some people might be tempted to do something like, oh, carbon you divide by 3, and the hydrogen, this is 6 divided by 3, and oxygen you don't do anything. If you don't do that, that's wrong. But if you divide this 1 by 3, then you will not have a whole number. Okay, if you don't do that, then it's wrong. If you do that, you don't have a whole number. So that means this original formula is already the most simple. And in other words, C3, so if you write C3H6O, that's already the empirical formula, which happens to be the same as the chemical formula. Okay? So now we have perfectly understood what an empirical formula is. Now let's see how we can find the empirical formula from mass or mass percent composition directly. Okay? All right. So step 1, basically you write down the mass of each element. For example, if I give you any grams of each element, you put it down. But if they give you mass percent, you're going to look at examples. So if you're still confused right now, it's okay. We'll give you specific example. If they give you mass percent, for example, one compound is made of carbon and hydrogen, and we give you 26% of carbon and 74% of hydrogen. How do you write out the mass? You simply assume 100 grams, and then you know the percentage times 100 is the given mass. Okay? All right, we'll look at examples. So then once you have grams, do remember grams can be converted to moles. So grams to mole. So the real first step, that would be grams to mole for each element. For each element. Okay. Once you have grams to mole, everybody would have a mole. You write down the so-called pseudo formula in which you use the moles of each element as the subscripts. Okay? Then you divide the subscripts in the formula by the smallest subscript. If the numbers are not whole numbers, you multiply this by a small number until they arrive at the whole number subscripts. If all numbers are whole numbers already, of course, that would be the empirical formula you have already. Okay? All right. So let's look at one example. For example, in this example, we give you 3.24 grams of sample of titanium reacting with oxygen. Okay? And it forms certain metal oxide. So in this metal oxide, it must be titanium and oxygen. Okay, when you react with oxygen, oxygen is O2, but when you combine them, it's the ratio between titanium and oxygen atom, not O2. So let's say you have X, Y. So basically we're asking you, what's the subscript X? What's the subscript Y? So how do we do the calculation? Okay, so that's the question. But how do we do the calculation? We need to calculate the mole ratio. So for example, if I go forward, if I know the formula, okay, I can go backward. I can know, oh, for this 1 mole of FeO2, I know you have 2 moles. The ratio between iron would be 2 moles of iron and 3 moles of oxygen atom. Okay, so we do know the ratio. But if you know how many moles of each, can you go back and calculate how many grams of each you have? Of course, it would be how many grams? It's 2 times the molar mass of iron, which is 55.85. So that's how many grams of iron versus how many grams of oxygen atom. Each oxygen atom, not O2, it's O, because we are talking about ratio between Fe and O, not Fe and O2. So it's Fe is 2 times of that. 3 times of this is number for grams of oxygen. You see, when we go forward, if we know 1 mole, if we know we have 1 mole of Fe2O3, okay, then you can go back and find out how many grams of each element. Okay, so how about if we cover this thing, so we tell you how many grams to begin with. Can you go back and find out the formula in Fe and O combination? So now we come back, we say, hey, can you find out the X and Y? Sure, then we go backward, right? So we have grams of each, so we convert them back to moles of each. Then we can find the mole ratio, right? That's the idea behind the 5-step procedure we just went over, okay? So in this example, it has titanium and oxygen. We need to find out what the X is, what the Y is. X and Y being the smallest whole number ratio, okay? So for the first step, we need to know how many grams of each element. Titanium, we know it's 3.24, which is given. But how many grams of oxygen? So the total metal plus oxygen is 5.40. So for oxygen, it would be 5.40 minus 3.24. This gives you grams. Again, it's O, because we need to find out the Ti, titanium, in the O ratio, not O2 ratio. Okay, so that's the first step. You have grams, then you can convert grams to moles of each element. Okay, so let's do that. This is grams of titanium. All right, the other one is oxygen atom. So you do the difference of the two, because we know the metal oxide contains both titanium and oxygen, right? So do the difference of the two, that gives you oxygen mass. Okay, now you do the calculation of moles by what we have already done, converting grams of one thing to moles of one thing. So denominator is the grams, it's using molar mass. Okay, so let me rewrite it, because sometimes you're more accustomed to doing it differently. For example, you can write it this way. You can do 3.24 grams of titanium times, remember, you gotta cancel out grams of titanium, so, and convert to mole of titanium. 1 mole is formula mass grams. Look it up in your periodic table for titanium. That is 47.867. So this gives you this number. Similarly, for the second step, I'm going to rewrite it. Mole of oxygen, okay, is when you try to calculate mole of oxygen, how do you convert grams to mole? You have 2.16. That's what we just did. What? So 2.16 grams of oxygen. Again, I'm writing in a different way, so you cancel the grams of oxygen, and 1 mole of oxygen is the numerator, so you do the calculation. Okay, so you have moles of both. Okay, now if you have moles, we will be able to figure out the mole ratio. Why is that important? Let's look at the previous example for one more time. Okay, if you know grams, so let me erase this. So if you know grams of each, you can go back and find out moles. Then you can go back and find out the mole ratio, and you find out the X and Y. So that's why we need to have grams being converted to moles, because with that we can find out the mole ratio, so we know how many atoms are in the compound. Alright, so we have moles of each. That's the smaller number of mole. That's the mole of oxygen. Both are divided by the smaller number. You got to divide both So the ratio will stay the same. In this case, it gives you a smallest whole number ratio, 1 and 2 already. So this is the empirical formula. Okay, let's look at a few more examples. I want you to work on this on your own and make sure you are 100% clear about how you do this calculation. Okay, all right. So in this particular question, we are asked how to find the formula, empirical formula for a compound given certain percentage of the component elements. How do you do that? In the 5-step procedure, the key procedure is converting grams to mole, and then use the moles as the subscripts and divide the subscripts by the smallest mole of any elements. Okay, so that's how you do it. So first you convert grams to mole, then use the moles as the subscripts, which is so-called a pseudo formula. Divide that by the smallest mole, you will have a clear idea after that. Okay, so let's work on this. So first, we got to have how many grams? It's assumed you have this many percentage. How many grams do you have? So if you have 100 grams or 1 grams or 2.54 grams or 6.73 grams, it will not change the percentage. Okay, so for the convenience of calculation, usually we just assume you have 100 grams total. So the percentage, the number of percentage will be the number of grams of each element, right? So here, when you do the calculation, let's say you assume, you don't have to write it when you do multiple choice, but for teaching purpose, I'm going to write this out. So you assume 100 grams of total sample. So this will give you correct number of grams for each element. So this will give you 14.5 grams of hydrogen, okay, and 85.5 grams of carbon. Hey, do you remember the real first step is actually, again, you know the grams, you're going to convert this to mole. How do you convert it to mole? Grams to mole, it's just that use molar mass. Okay, why do I write the grams of hydrogen as denominator? Because you want to cancel it out. Okay, we do know molar mass, 1 mole of hydrogen. Look it up in your periodic table. Okay, 1.08. So you do your calculation, and we're going to find out how many moles we have. At 1.01. Okay, so let's do a calculation and find out. So it's 14.4 mole of hydrogen. So similarly for the second one, we need to cancel the grams of carbon. So grams of carbon for the conversion factor must be the denominator, so we can cancel this out. So how many moles of carbon? We know it's molar mass, so it's 1 mole is 400 mass grams. Look it up in your periodic table, it's 12.01. So let's do this calculation using our calculator. So 7.12 mole of carbon. Okay, so that's the you might say, assuming that's number of grams, that's first step. Okay, that's the second step, depending on how you call it, but the real first step is convert grams to mole. Okay, now what is the third step? The third step is convert the pseudo formula to the empirical formula by dividing the subscripts, smallest, the whole formula by the smallest subscripts. So what is the pseudo formula? The pseudo formula, you have carbon, and you know it's 7.12, okay, mole. Hydrogen is 14.4. Okay, so you do this calculation. You divide both by the smaller one, 7.12. Okay, and this gives you C1H. So the next one we're going to use the calculator. That's 14.4 divided by 7.12. This gives you a 2.02. Okay, and this 2.02 is small enough between the 2 and 2. That's between 2.02 and 2. That's close enough to number 2. So that's why we round it to 2.0 or just this 2. Okay, if it's 2.5, you cannot round it. Okay, all right. So the correct answer will be B. Let's look at another example. Okay, hopefully we can have a lot of practice in this way. All right. Again, I strongly suggest you work on these examples before you look at the answer. All right. Okay. In this answer, we are given percentage of each element: carbon, hydrogen, and oxygen. Okay. So do remember the two key steps. The first is convert grams to mole. Two key steps. First is grams to mole. The second key step is so-called pseudo formula. What is pseudo formula? Pseudo formula means you use the moles as the subscripts. You convert it to an empirical formula. How do you do that? You divide the pseudo formula by the smallest number of moles, right? So that's how you do it. So if I summarize it, the whole 5-step procedure can be just written as grams to mole. That's the first step. Then you convert pseudo formula to empirical formula. Let's do that. Since the percentage is given, so we assume 100. We assume 100 grams of total sample. Okay. So we do know you would have this many grams of carbon and this many grams of hydrogen and this many grams of oxygen. Okay, so first step, we got to convert grams to mole. All right, so 60.00 grams of carbon convert to, so grams, let me write carbon. So it's grams of carbon convert to moles of carbon. 1 mole is 12.01 grams. Do the calculation. And we're going to do it a little bit later. Okay. Then the second one, you have 4.48 grams of hydrogen. You convert this to mole of hydrogen. So grams of hydrogen, mole of hydrogen. Grams of hydrogen is cancelled out. 1 mole is 1.01 grams. So we're going to calculate that a little bit later. Right. Next we have 35.53 grams of oxygen times, again, grams of oxygen is cancelled out. So 1 mole of oxygen is 16.00 grams. So let's do this calculation. So let's do this calculation right now. Turns out the first one is 4.996 number for moles. Let's do the second one. 4.436 moles. Right. Let's do the third one. 2.221 mole. So we have successfully converted grams to mole. Now we will have the pseudo formula using the moles as the subscripts. 4.996 hydrogen, 4.436 oxygen, 2.221. So 2.221 is the smallest. We divided everything, remember, divided every subscript by the same smallest whole number. All right, so this gives us it's carbon 2.25 H. You have 2, oxygen you have 1. Hey, remember, we cannot round 2.25 to 2 because 2 and 2.25 is not close enough. Okay, if you see, for example, if you see 2.25, you actually multiply 4, it will become a whole number. If you see something like whatever 0.5, 2.5, 3.5, whatever 0.5, you multiply by 2. If you see something like 1.33, 0.33, whatever, then you multiply by 3, they will become a whole number. Okay, so this whole thing you need to multiply by 4. So if you multiply by 4, carbon becomes 9, hydrogen becomes 8, oxygen becomes 4. So this gives you A as the correct answer. So let's summarize this. The procedure is very, very similar, almost identical. Okay. First, you convert grams to mole. Second, convert the pseudo formula to the empirical formula by dividing by the smallest number of moles. The difference is, after you divide by the smallest number of moles over here, for carbon, you don't have a whole number or a number really close to a whole number. So for this reason, we will have to multiply the whole formula by a certain number, so they will become the smallest whole number ratio. In this case, for 2.25, you multiply the whole formula by 4. All right, let's do a last example. All right, in this particular example, we are talking about the relationship between the empirical formula and the molecular formula or chemical formula. So let's review something we talked about in the very beginning of this topic. As we know, for example, if the chemical formula, let's say in chemical formula, if chemical formula is C6H6, the empirical formula so apparently it would be CH, right? So what is the relationship between the empirical formula and the chemical formula? You would be able to see this easily. That would be C6H6 equals empirical formula, that's CH, the whole thing times 6, right? Or you could do another one, C3H6. What's the empirical formula? Empirical formula would be CH2. What's the relationship between the two? The chemical formula is empirical formula CH2 times by a whole number. Did you see that? So in other words, if you make it general, you always know the chemical formula, okay, is always empirical formula times certain whole number. Empirical formula times a certain number. Let's use n to represent it. So in this case, we know the empirical formula of the compound is found to be CH2O. Okay? Then we know the molar mass for the molecular formula. Hey, remember, molecular formula is the same as the chemical formula for molecules. It's just a different name for chemical formula. All right, I just erased everything. So we do know molecular formula or chemical formula, which is the exact same. Molecular formula is empirical formula times n. Okay, we know molecular formula over here has a molar mass as 180. Okay, and the empirical formula here is a CH2. So let's substitute this in. So 180.2 is CH2O times n. So what's the molar mass for CH2O? So basically CH2, what's the molar mass? It's 1 carbon plus 2 hydrogen plus 1 oxygen. 1 carbon is 12.01 plus 2 times 1.01 plus 16.00, 30.03. Right. So we go back. So this gives us 30.06 times n. Okay. So what is n? N will be 180.02 divided by 30.06. Okay, I mean 18.2, not 0 to 18.2. So this gives us, so you do this calculation. This is 6. Alright, so what is the molecular formula? Molecular formula is CN2 times 6. So C6H12O6. So C is the correct answer. Alright, hopefully you'll go back and work on a lot more examples, because for sure this will be tested in your quizzes and in your exams, your exam number 2 and your final exam. Alright, that's it for today. Have a great day. Bye.